Everyone, welcome back to Kazimula Applied Sciences. Today I'm looking at alkenes, how they react basically in addition reactions. But in order for us to understand how those addition reactions work, we need to just quickly remind ourselves again of the structure of alkenes and how that will affect how alkenes react with other molecules. So as you can recall, unlike alkanes, alkenes cannot rotate freely about the double bond. Now, as you can remember, alkanes have only single bonds between carbons, but alkenes have double bonds between carbon atoms. A double bond consists of a first bond between carbons, which we call the sigma bond, and then a second bond, which we call the pi bond. Now, the pi bond is basically an overlapping of the p orbital sideways in order to make that and create that one bond that basically runs above and below the level of the carbon chain. And that we call a pi bond. A pi bond is quite a weak bond, but it restricts the motion of the carbon atoms that are bonded within that pi bond so that they don't rotate freely around one another. Of course, if you put in a lot of energy, then you can break that pi bond and you will end up with the two original p orbitals that have overlapped to form that pi bond. So let's move on to the reactions of alkenes. Here I've got a typical alkene called, of course, ethene, and we've looked at the naming of alkenes. There are two carbons, so this is an eth, and there's a double bond, so the suffix is ene. This is ethene, and it reacts with a halogen, which of course is bromine, right? This is a halogen, and when they react, the pi bond on this alkene will break because it has some energy in the form of heat or whatever the reaction conditions might be. That pi bond will break and then open up sort of like a double gate, and it basically add on the molecule, these two separate atoms of bromine, the halogen, onto the carbon chain. We call that addition. Please take note of the following. Two atoms, in this case, two bromine atoms in this diatomic bromine molecule, add across the double bond. One pi bond is therefore replaced by two new sigma bonds. This original sigma bond between the carbon atoms will stay, but the pi bond is broken and made way for two new sigma bonds onto those adjacent carbon atoms that were involved in the pi bond, and you'll have new atoms adding onto those carbons, and that we call addition. There are four types or common addition reactions I like to call the 4 H's. Now, the 4 H's are halogenation, hydrohalogenation, hydrogenation, and hydration. Now, as these names of these 4 H's, addition reactions, imply, the element that you add or the molecule that you add to react with the alkene is given in its name. Now, if a alkane undergo halogenation, a halogen will be added onto the chain. So in this case, let us look at, for example, bromine, which is, of course, a halogen. It's in group 7. Okay, any element from group 7 is a halogen. If that's added onto an alkene chain, then that would be called halogenation. And as we said, in a double bond, there is the first bond, which is a sigma bond, and the second is a pi bond, right? That pi bond is much weaker than the sigma bond because of the sideways overlap of the p orbitals of those adjacent carbons. And so that's quite a weak bond. But I want you just to get a visual of this and sort of make it easy for yourself. Think of the pi bond as a gate, right? And it's like this double gate that can open like this, and they make way for two elements that can be added onto these adjacent carbon atoms. They are added onto the chain, and so we call that addition. Specifically, halogenation, because two halogen atoms have been added onto the chain. And this pi bond has now made way for two new sigma bonds that are formed where these bromine atoms have added onto the carbon chain. Now, with hydrohalogenation, of course, you're going to add a hydrohalogen. So it's something like HBr or HCl, HI, HF, right? Any sort of acid we call a hydrohalogen. And if that adds on to the pi bond, it opens up and it adds on to those two adjacent carbons. We call it hydrohalogenation. You get two products, a major product and a minor product. And I'm going to explain to you what the difference is. When we add hydrogen onto the alkene chain, then of course we call that hydrogenation. And again, your sigma bond is the first single bond between the carbons. Your second bond is your pi bond, which will open up like a double gate and add the two H atoms on those adjacent carbons. And now you go from an alkene to an alkane. You go from something being unsaturated to a compound that is now saturated. And this is typical of addition reactions. Hydration, you can think of when you hydrate your body, you hydrate yourself, you're drinking water, you're adding water into your system. And so the same when there's hydration, that type of addition reaction is involved between water being added and the alkene. So yet again, the pi bond will open up and you'll have water adding. Now, if you just think of what water is, that's basically just H bonded to OH, right? And the H will go sit on the one carbon and the OH on the other carbon, as you can see here. And now what have you got? You've got an ethanol as product. We will look at the mechanisms of how these addition reactions work in order for you to understand better. Stay tuned.